Okay, so we're on example 12, which is this inequality, x minus 2 greater than 4 over x plus 1. And you might be tempted to multiply both sides by x plus 1. Then you would get x plus 2, x minus 2 versus 4 and a 4. But the problem is x plus 1 could be positive or negative. So if it's negative, you have to flip the sign, and it would go the other way. If it's positive, you don't flip the sign. So it's annoying. And that's the answer in part A. Explain why multiplying both sides creates an issue. It's because x plus 1 could be positive or negative. So you can't be sure of that one. And you can do it sort of in cases by thinking about these two cases. But we're going to do it another way. And the other way is to do this. X minus 2. We're going to take the minus 4 plus x and minus 4 over x plus 1 and move it to the other side. So it looks like that. We just took 4 over x plus 1 and moved it to the other side. That's subtraction, so it doesn't involve any flipping. And now I can do common denominator. Common denominator to get x minus 2 times x plus 1 minus 4 over x plus 1. So if I make a common denominator of x plus 1, I'm looking at this guy. And the top, I can expand x squared minus x plus minus 2 minus 4 over x plus 1. Excuse me. And this guy I can factor x squared minus x minus 6 over x plus 1 greater than 0. Okay. And that's x minus 3 times x plus 2. That's an easy one to factor over x plus 1 greater than 0. And now this is perfect for my number line method. So a lot of things that don't look number liney, if you move them over in the right way, you can make them look number liney. So I'm going to have three factors. I'm going to have x minus 3, x plus 2, and x plus 1 in my table. What are the important points on my number lines? I think there's going to be x is negative 2. That comes from the x plus 2. There's going to be x is negative 1. And there's going to be x equals 3. Those are all important points on my table. And once again, these are lines. So just like all the other problems, you can imagine the graph in your head, or if you want, you can draw the graph. X minus 3 looks like this. X plus 2 looks like this. X plus 1 looks similar, like this. So I can see all these functions, because the slope is positive, they're negative up until their root, and then they're positive afterwards. So x minus 3 is going to be negative, 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 positive. X plus 2 is negative, positive, positive, positive. X plus 1 is negative, negative, positive, positive. Okay, and then I gotta put them all together. What is happening to the function f? Negative, 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 negative. Two negatives, that's positive. A negative, negative. Three positive, that's positive. So f goes negative, positive, negative, positive. Final answer to the question. Question says, where is it positive? Where is it positive? Therefore, let's write it in words. So f of x greater than or equal to 0 when, on which two intervals? From negative 2 to negative 1 and 3 to infinity. Negative 2, negative 1, and 3 to infinity. Okay, and you got to be careful about the brackets. Do you include these points or not? So 3, okay, infinity is never included. Open bracket there. Should I include 3? Well, at x equals 3, it's 0. So that's included. Should I include negative 1? Negative 1, you're dividing by 0. So negative 1 not included. Should I include negative 2? At x equals negative 2, x plus 2 is 0. So I should include that. So there you go. That's the final answer. Negative 2 to negative 1, union 3 to infinity, with the brackets including the 3 and the negative 2, but excluding the negative 1. There you go.